Hello, my dears. Welcome to today's lesson, An Intro to Matter. By the end of this lesson, you should be able to define matter and identify things that are and are not matter. You should also be able to list and describe the 5 states of matter. Let's get started. Matter is a term that comes up a lot in science, so it's important to have a common definition here. So matter is anything that has volume and has mass. Now that's a good place to start, but what are volume and mass? Volume is maybe a term that you have heard in math before or seen in math before. Volume is the amount of space that an object takes up. In math, we calculate volume by taking the width of an object, the length, and the height, and we multiply them together. Even objects that look like they're flat, like a piece of paper, have volume to them. Now, our other term that we used when defining matter was mass. Mass is the combination of the total number of atoms, considering their density and the type of atoms that you have in an object. Now, that's a little bit tricky, so we want to dive deeper with that. We saw in a previous class that atoms are made up of protons and neutrons in the nucleus and electrons around the outside. We call that the orbitals. So when we're talking about mass, we're actually talking about the added number of protons and neutrons that are in the nucleus. So anything that has atoms is going to have protons and will probably have neutrons, which means it has mass. If it's made up of atoms, it has mass. Now, a lot of times students think of mass and weight as the same thing. They are not. I really want to emphasize that. These are not equal ideas. Mass is really determined by how many atoms do you have making up an object and what is the number of protons and neutrons in the middle of them, whereas weight has a lot more to do with the gravity of a planet. All right, so these are not interchangeable terms. I never, ever, 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 ever want to hear you define mass by saying it's like the weight of something. It's not. So here we can see some examples of matter. We know that each of these things is matter because they have volume, they take up space, and they also have mass. They're made up of those atoms. Some of these things might make a lot of sense, like a chair and a cat and a plant. But some of these things might surprise you, like the sun or a cloud. Remember, these are things that take up space, so they have volume, and they're made up of atoms, so they have mass. So those would also be considered matter. Now, matter can be divided into 5 different states. When we say state in this situation, we mean form in which it can exist. The first state of matter is a solid, and this might start to sound familiar to you. You might be like, oh my gosh, I learned about this in elementary school. We're going to go a little deeper today. So what makes a solid a solid? Well, in a solid object, the matter is composed of atoms that are tightly packed together. It has a definite shape and it has a definite volume. What I mean by that is if I took a table and I put a ball onto that table, it would stay in ball form, right? The shape would stay the same and the amount of space that the ball was taking up would stay the same because it's a solid. Examples of this are ice and a rock. Our second state of matter is liquid. The atoms in liquids are loosely packed together. This means that liquids do not have a definite shape. Instead, they take the shape of a container. However, they do have a definite volume. So what do I mean by this? If, again, we took our table example and we poured water onto the table from a cup. When the water was in the cup, it would take the shape of the cup. When the water is poured onto the table, it goes everywhere, right? Because it doesn't have a container to go in. However, the amount of space that that water is taking up is going to be the same. It's a definite. If you have 100 milliliters of water in this cup, now you have 100 milliliters of water all over your table. Examples are liquid water and orange juice. Our third state of matter is gas. Gas is matter that is composed of atoms that are very loosely packed together. As a result, gas does not have a definite shape or a definite volume. Essentially, it takes the shape and it has the volume of whatever it fills. So, for example, if I were to put air into a balloon, the amount of space that that air is taking up would be the container, the balloon. And the shape that the gas is in is the same as the container, that balloon. Examples are water vapor and oxygen. Our fourth state of matter is plasma, and this is where things start to get new and weird. Plasma is essentially a gas. However, you take that gas and you superheat it so that the electrons leave the atoms. So for example, here I have an atom that I've drawn. Remember that the electrons are the things that are on the outside, so these things start to just basically kind of fly off. As a result, your plasma does not have a definite shape and it does not have a definite volume, but it's going to behave a bit differently than a gas. Some examples of plasmas are stars, plasma TVs, the displays are actually plasma, and then lightning. Now on Earth, we see plasma very, very rarely, but fun fact is that over 99% of matter in the visible universe is actually thought to be plasma. So on Earth, very rare, but in the universe, very common. Our last state of matter is called Bose-Einstein condensate, and this is probably one that your parents haven't even heard of because it's pretty recently discovered. Bose-Einstein condensate, you take a gas, only this time you supercool it so that all of its atoms behave exactly the same. So even though it's a gas, with that supercooling, it has a definite shape and it has a definite volume. This is pretty advanced stuff, but in case you are interested, this would be some examples would be things like superfluids and superconductors. So in summary, what we've seen so far, matter is things that have volume and mass. There are 5 states of matter, and the state of matter is determined mostly by the arrangement of atoms. Are they tightly packed together or are they loose? The shape, is it definite or not? And also the volume. All right, my dears, I look forward to seeing you in our next lesson.